Hey guys, welcome to Unit 9, Lesson 4. Our topic today is velocities and rates of change. In this lesson, we are going to be interpreting particle motion problems given an equation instead of graphs. So the warm-up says a particle moves along the x-axis in such a way that its position at time t for 0 to 5 seconds is given by s of t equals t cubed minus 6t squared plus 9t minus 2. So we are given a position equation and we want to find out its relationship with velocity and acceleration depending on what the question is asking. So part A, again, our vocab we have to be really good with it. You must understand what the question is saying. Always look for the justification, and that will help you find the answer. The velocity at time t. So again, we are given a position equation, and we want to determine what is the relationship between velocity and position. Remember, velocity is the first derivative, and it is the derivative of my position. So basically, v of t is equal to s prime of t. So we want to find that. So what would be the derivative of this would be 3t squared minus derivative of 6t squared would be negative 12g. Derivative of 90 is just 9 and 2 goes away. So that is my velocity at time t. So find the acceleration at time t. So what is acceleration? Again, go back to the relationship of velocity and position. Acceleration is the first derivative of velocity because it's the rate at what it's changing, and the second velocity is changing, second derivative of your position. So basically I'm going to be taking the derivative of this, which would be 6t minus 12. What are the values of t for which the particle is at rest? Again, when is the particle at rest? When velocity is equal to 0. So my velocity, I already know the equation for velocity was what? 3t squared minus 12g plus 9. I'm going to set it equal to 0. And I'm going to factor it here. I can first factor out the 3. I'm left with t squared minus 4t plus 3. And then this would be t minus 3 and t minus 1 equal to 0. T it out. Oh, I divided by 3 here. Could have gotten rid of the t. So t is equal to 3 or t is equal to 1. So when is the particle at rest? At time 3 or 1 second. So it at both places it is at rest. Is the speed increasing or decreasing at x equals 4? Explain your answer. So again, whenever we talk about speed increasing or decreasing, we are comparing velocity and acceleration. So if your velocity and acceleration have same signs, it is increasing. If it is velocity and acceleration, I'm going to write it here, have different signs, or I would say opposite sign, your speed is decreasing or slowing down, whatever you want to say. So here it's asking us at t equals 4. So I'm going to find v of 4, which would be 3 times 4 squared minus 12 times 4 plus 9, which would be what? 4 squared is 16 times 3 is 48 minus 48 plus 9, which is just 9, right? Which is what? Positive. So velocity is positive. I'm going to do the same thing for my acceleration at 4, and I'm going to use my equation that I found for acceleration, which is 6 times 60 minus 12, right? So 6 times 4 minus 12, 6 times 4 is 24 minus 12, which is also positive. So this is positive, your velocity is positive, so the speed of the particle is what? Increasing. So let's write this down because it says explain your answer. The speed of the particle is increasing because velocity and acceleration are both positive. We have already looked at particle motion graphically. Now let's look at what happens when we try to analyze motion by using the position equation. So our position equations are given to us and we want to answer the questions based on the knowledge we have and the relationships we know. Again, remember your position graphs are usually denoted by x of t or s of t, and the first derivative of x of t is your velocity. The second derivative of x of t is your first derivative of velocity is your acceleration. So we need to identify those things, right? The first question, a particle moves along the x-axis so that at time t greater than or equal to 0 hours, its position is given by x of t equals t cubed minus 3t squared minus 9t plus 2 miles. So this is our position equation given to us. We want to find at t equals 0, is the particle moving to the right or to the left? Justify. So again, think about your justification. When is the particle moving to the right? When your velocity is greater than 0. When is the particle moving to the left? When velocity is less than 0. So that's basically our explanation or justification. So I want to first, I don't even know v of t. So I'm going to find v of t, which I know is the first derivative of my position. So t cubed, derivative of t cubed is 3t squared minus 3t squared would be 6t and 9t would be just 9 and 2 goes away. And now I want to find at 0. So v of 0, which would be what? Negative 9. Negative 9, so it means what? The negative means you're moving to the left because negative 9 is less than 0. So we are moving, or the particle is moving left. Therefore left, right? So part B, it says at what times does the particle change its direction? So we've not talked much about it. So when does a particle change its direction? When v of t changes sign, right? So how do we determine that? First, we want to determine where the particle is at rest or is equal to 0. So let's do that. This would be what? When your particle is at 0 means your velocity is equal to 0. So velocity is 0 would be, I'm going to take my velocity equation and I'm going to set it equal to 0. I'm going to factor out my 3 and I'm left with what? T squared minus 2t minus 3 is equal to 0. I'm going to divide by 3. I'm going to factor the inside. So what do I get? T minus 3 and t plus 1 equal to 0. I'm going to set them equal to 0. So I get t is equal to 3 and t is equal to negative 1. So we're going to ignore when t is equal to negative 1 because we're only considering t to be positive, equal or greater than 0. T is only equal or greater than 0. So now what we're going to do is we're going to be drawing a velocity number line. And why do we need to do that? Because we want to find when t is changing direction, right? When it's changing from positive to negative. So I'm going to use my number. I'm going to start at 0 because the t is greater than or equal to 0. I'm going to place 3 right here. So I would pick a number from each interval to determine what is happening during that interval. So I would do what? V of 1. Let's do V of 1. So between 0 and 3, I am going to pick 1. You could have picked 2 also. Any other number. 1 is easier to calculate. So I'm just going to substitute t with 1 minus 6 times 1, which is 6, minus 9. I get that to be negative 12. Yes, right? Which is a negative number. So between 0 and 3, it is the direction is it's moving left. So the next number I'm going to pick is between 3 above 3. So let's pick 4. So I'm going to do 3 times 4 square minus 6 times 4 minus 9. So that is actually a positive number. It is actually positive 15, right? So since it's positive, at 3 it was at rest. So what is happening is it's changing directions. So what does that mean? That since it is going from negative to positive at t equals 3, write this here, t equals 3, the particle is changing direction. Part C. At t equals 1/2, is the velocity of the particle increasing or decreasing? So again, what do we know about velocity? Velocity is increasing when your acceleration is what? Greater than 0, and it's decreasing when your acceleration is less than 0 or negative. So what's the relationship between acceleration and velocity? Acceleration is basically how fast velocity is changing, right? So acceleration is the first derivative of velocity. So if I take the derivative of velocity, it would be what? 6, I'm just going to change colors here, 6t square, 6t minus 6. So that is what my acceleration is, and I want to find it at t equals 1/2. So I'm going to just substitute t with 1/2. It is 6 times 1/2 minus 6 equals negative 3, right? So what is the negative? Again, the negative and positive do mean a lot. Negative means that velocity is decreasing your acceleration because your acceleration is what? Less than 0. So velocity is decreasing because acceleration a of t is less than 0. Part D. At t equals 1/2, is the speed of the particle increasing or decreasing? So anytime we talk about increasing or decreasing, we are comparing our velocity and acceleration. It is increasing when both acceleration and velocity have same signs. I'm going to write have same sign. It's decreasing when velocity and acceleration have opposite sign. Right? We're comparing the two. So here I want to find v of 1/2, which would be what? So I'm going to go to my v function. I'm going to substitute in 1/2, which is 3 times 1/2 square minus 6 times 1/2 minus 9, which would be negative 45 over 4. And a of 1/2 would be what? We want to compare them. So if we get this to be negative, so 3, this would be 6 actually. 6 times 1/2, which is 3 minus 6, which is negative 3. Right? We got negative here and negative here. They both have the same sign. If they both have the same sign, then means what? The speed of the particle is increasing. right? So let's write that down. Since a of t, a of 1/2, or I would say a of 1/2 and v of 1/2 have same signs, speed is increasing. Increasing. Okay, so let's try part E. It says find all values of t for which the particle is moving to the left. So when is particle moving to the left? When your velocity is less than 0 or negative, right? So I can actually look at we already did this. If I look at my velocity number line, I was starting at 0 and I knew it was at rest at 3. It was negative here and positive here. So where was the particle moving left? So between 0 and 3. So in that interval. What is the particle's acceleration at t equals 1/3? Explain with units the meaning of your answer in terms of particle's velocity. So I already know my a of t. I'm going to find a of 1/3, which would be 6 times 1/3 minus 6, which is 2 minus 6, which is -4. And it will be what? Miles, right? It is miles. My velocity units are miles per hour, so it'll be miles per hour square, right? What does that mean? Remember, your acceleration is the rate at which the velocity is increasing or decreasing, or velocity is changing, right? So the velocity is, since it's negative, it's what? Decreasing at a rate of 4 miles per hour square. So finish up the remaining problems for lesson 4, and if you have any questions, please reach out to me. Good luck.